Hello, and if you saw the Dev Keynote from Next, you already know what I'm going to talk about. But if you didn't, or you want a little bit more detail, this is the session for you. We are in the Dev Keynote, we showcased agent built out with multiple agents working together, including tools, including different aspects of how to build an enterprise-ready, production-ready agent. And a part of it, we started off somewhere, and that we started with something called the planner agent. Now, we have a marathon, and you know, plan. It's a fairly complex process. And this is something we did with basically human intelligence, with time and a lot of people working together, designing an agent, not agents, designing the plan, designing the race and everything. And we took the task of, okay, can we take that process and make it so that a bunch of agents working together can do the same thing, if possible, even better. And started off with building an agent. And when you go to build agent in 2026, you have a lot of options, and we believe that ADK, Agent Development Kit, is the best way to do this. And ADK, if you're familiar, if you're not as well, ADK is an open source project that we started at Google, but it's open source, so anybody can access it. And any language you prefer, like usually, again, the main library was built in Python to start with, but after that, we also have libraries for ADK in Go, TypeScript, and Java. So whatever language you prefer, we have something for you. So that's our base. We build the agent on that. But agent just on the language and the model. And then for the models, we have many choices. We obviously believe Gemini models that we have available, Gemini 3, 3.1, the Flash, the Pro, all of that can give you the compute power needed for the agent's brain to do things. But you can choose any model that you want, right? Like you can bring in Claude models, GPT models, your open models that you're running on GKE yourself or like any other place. So you can bring the agents with the model. Now you have the agent, now you have the agent's brain. But that is so 2025. You have the agent and the model, but that is not all you need to have the agent be intelligent and do things into the world on its own. The next two things you would need for the agent, that would be the skills and the tools. Now, tools are just functions, right? That tool function can be just a compute that is happening as the model needs to compute something, but that tool call can also be affecting some other service. It could be an MCP server the agent is talking to. It could be some database the agent is accessing. And then you have skills. So skills are a fairly new concept. The way skills work, it's you have basically two parts to a skill. You have the YAML metadata and you have the markdown body, right? So the YAML metadata is fairly short. It just describes what this tool's name is and what is the core thing that this skill does. And when the agent basically starts up, it will load up all the skills it has in the context. So it has all the skills and only has the information of the YAML metadata. Now it knows I have 7 different skills, let's say, and each of the skills do X, Y, and Z. And then when I have a task that fits one of the description, then I can go off and get the rest of the markdown body, which can be fairly long, which can have code, which can have scripts, which can have other references going off onto something else. So you can have your context be fairly short because you are just loading a short amount of description. And then once you have loaded all of that, once you need that particular skill, you can go off and download the rest of it. So all of a sudden you have this fairly clean context, but the tools you need, you get them in point. So tools, skills, together, you can have a fairly clean context. And once you have done all of that, now your agent is no longer just dealing with prompt. It is efficiently managing context and doing the task you need to do. Before we jump any further, I want to quickly show you, if you missed the demo, what we're looking at. The app we built out is the simulation application, is this beautiful simulation of Las Vegas in 3D. And this simulation application, and we're looking at the first version of it, the one I'm talking about here. We're sending in a prompt saying, plan a marathon in Las Vegas for 10,000 runners, right? And I'm gonna go ahead and send this prompt off. And what we're going to see in a second, what happens, is we're gonna start seeing that a tool call happens, load skill, GIS spatial engineering, then plan a marathon route, then load a skill called mapping, then we load a skill called race director, right? So again, our agent started doing the work, and as it was going through it, it found, okay, I need to have this particular skill because at this point in my prompt, it looks like the task I have at hand would be better if I had a specific skill loaded, right? So after all of that, so there is a bunch of things happened, right? Let's talk about each of these skill a little bit more detail. I'm gonna look at the code just in a second too. GIS spatial engineering skill has access to a Python script, which is taking a GeoJSON data and calculating a viable route that would fit our marathon criteria. One of the key ones is the length, like 26.2 miles or 42.195 kilometers. Very specific. So we are doing some very specific mathematical operations on those like route coordinates to find a route that goes through Las Vegas and satisfies that criteria. After that, we have some other criteria like, okay, we don't want to have elevations in the back half of the marathon. We want to have water station placed in a certain locations. All of that is being calculated through code. We don't know our model to randomly guess or make up that information. That information has to be grounded to the real world somehow. So we're doing that by calculating GeoJSON data that way. We have another skill called mapping. So mapping skill here is actually taking advantage of Google Cloud Remote MCP for Google Maps. So Google Maps, again, all of you know, Google, we have been mapping the entire world for years now at this point. So we have a lot of information about each location, each coordinate of the world. So what is there? What kind of things are there? On top of that, the Google Cloud Remote MCP for Google Maps, we also have information about weather information. So if you're trying to plan a marathon, you probably don't want the marathon to happen in a really hot day or a really cold day or a really rainy day. So with that historical weather information, you can start now planning a little bit better. So this one just calls the Google Maps API underneath, right? Google Maps MCP server is just a way for us to access the Google Maps API without having to know all the API query. We can just use natural language to talk to the Google Maps API. So we have, number one, we have the GIS skill, which calculates using Python code, handles the calculation there. We have the mapping skill, which now talks to Google Maps MCP server. And the last one we have is race director skill. Now the race director skill here, it's kind of requirements, but these are not hard requirements. These are just, if you're planning a marathon, you would probably have this documentation that says, okay, do these kind of things. Make sure the initial starting point have 3 or 4 lanes, because in the beginning, there are lots of runners that are trying to run through the same area. If the road is too narrow, you're gonna have a choke point. Or you need to have this many water stations spaced apart this many distance. Or something like you need to have this many porta potties, right? So all these requirements that are not necessarily directly required for the race itself, but absolutely required to have a successful marathon. So all of that information is not necessarily something hard-coded, but it's codified in text, and that used to live in a Google Doc. And what we did is basically take that Google Doc and talk to Gemini about, okay, this is my Google Doc, which is useful for humans to read, but not super easy for machines to read. So can we take that doc and convert that into a skill? And again, models are really good at summarizing or converting one type of text to another type of text. So that was pretty straightforward to take the Google Doc. We use the Google Workspace MCP server. We didn't really talk about that much, but we use the Google Workspace MCP server to pass the Google Doc as a link, and we can then convert that into a skill for ourselves. So this is on the right side, or where you see on the right side here, that is our simulation application calling into our planner agent. Now you might be wondering, okay, this is a nice UI and all, but how do I go about doing this all myself, right? So this is not just like we're just showing you this and you have to take our word for it. All of the codes that you see here are actually available in the GitHub repo that you can go run yourself. So we open sourced this repo yesterday as during next week open source it. So you can just go ahead to this repo. I'm also going to put the link on the video description later that you can go find it. It's called race condition. That's the simulation application. And within the race condition simulation application, we have a few different things here. First of all, this is, again, development in 2026. We took advantage of a lot of this coding harnesses like Claude, Gemini CLI, anti-gravity. So if you're using Cursor, Claude, Gemini CLI, any of those, you'd be able to go into this repo and you'll see this. We have agents.md files for Gemini.md file. And we also have Gemini skills that you can take advantage of. We also have things like Claude skills, right? If you're using Claude, you can use that to also help deploy or contribute. And then all the agents that we're talking about, the one I'm talking about is the first one to start off, which is the planner agent. And all the code is here. You can jump in and take a look at how each of these parts work and how they work together to do the things we do. But I want to quickly show you the skills we were talking about because there is a lot of them here. So GIS spatial engineering, just open up one of the skills. And I'm going to bump up the font a little bit because it makes it easier to read. So the thing we talked about, I'm going to take a look at this text in raw format so we know exactly what the agency is. So start off. We have a name, right? We have a name called GIS Spatial Engineering, and we have a description. Description basically just says it's a GIS tool, and it generates mathematically perfect marathon routes of exactly the right length. And after that, we have a bunch of body, right? The text, it says how it works, what it does. Now, in the beginning, on the model, only this part was loaded. We only loaded this into the context, and we also loaded all the other skills that we have in the system. After that, as the model was going through our task list, when it hit a point where we said, okay, calculate the route now, it knows, okay, I have this skill that says expert GIS tool for generating routes. At that point, it will go ahead and load the rest of the skill. We'll also see in a second, as part of the skill, we have something called scripts. Inside scripts, we have this function. And again, this is just Python code. It does a lot of mathematical calculation. It is fairly long. It is fairly verbose. So again, if you have the time to or you want to understand this, I would probably just load this up on Gemini and ask, okay, explain what this code does. But generally speaking, it is doing a lot of calculation on GeoJSON data. For Las Vegas, we also have this network.json file, which is a giant JSON file, GeoJSON data. So again, GitHub was nice enough to be able to create a map out of it because it's GeoJSON. It knows how to deal with GeoJSON data. But in reality, it is just a big JSON file with coordinates, with lines and things. So if you look at the mapping view, actually quite fun to see, we basically have all the points in Las Vegas that is mapped out. And you could see, and we almost made a geofence to say, okay, when you draw the map, make sure that the map doesn't go beyond the boundary. We don't want your marathon to end up in the desert, right? That would be a terrible end to a marathon. After running for hours, you end up in the middle of nowhere. That's not fun. So we can end you in a location that is geofenced by the Las Vegas city boundary itself. All right, so you have that skill, and then we can look at the other couple skills we talked about. The next skill we'll talk about is mapping skill. So mapping skill is going to be fairly straightforward because it basically just says, okay, when you need to have any mapping capability, go ahead and use the Google Maps MCP server, which itself comes with 3 different tools underneath, which is search places, compute routes, and look up weather, right? We're not going to take advantage of the compute routes. But again, you have to remember, Google Maps, the tool, is not meant for just calculating running routes. It calculates more like walking routes, bike routes, and car routes. We could use that to get general idea of the distance, but still it would be not as good of a calculator of a marathon route because they're very specific. We don't want any loops or crosses onto the route itself if we don't have to. So lookup weather is the one we're using. Another one we're using is search places, which is to find out information about individual points onto the map. Also find things like landmarks, because again, we don't want to have a marathon in Las Vegas where we don't see any of the famous Las Vegas attractions. So Google Maps search places would let us easily find the big places like, Bellagio, the Fountain, or the Sphere, all of these locations that we want our runners to be able to see. So that is that skill. And the final skill we have here is a race director skill, which is, again, it's a text-based skill. We basically took a Google Doc and converted that into the race director skill that we can have give some non-deterministic criteria a little bit and tell it how to plan the race well. We have a couple of other skills here that we don't use for the first agent, but they're still here. For example, when you plan a race this big, you need to have planning for how do you deal with cost and how do you deal with economic impact of having this race disruption to the city. Okay, so that is the code. We're going to link it at the end so you can go try it out. On top of that, on trying everything else, we also have access to a Codelab that we created out of this. So if you want to just go through and build this agent out yourself, it's going to be fairly straightforward to go and clone this repo. I'm gonna go to the repo myself. So all the demos we saw actually have Codelabs built out for them. So for Dev Key, we have the demo 1, and you'll see step by step how to get access to the code. This was probably an easier place to show you the restrictor skill. So yeah, this is just like a text-based skill. We also have another reference that is here that you can go, again, non-deterministic criteria, like for how many people, how much of like a wide road do we need? For a larger road, a larger amount of people, we want a bigger road because, again, a lot of people are starting at the same time, and how many lanes we need minimum, right? Bigger is better, but at least in the minimum, we need this. So traffic impact as well, like all these criteria, these are harder to calculate deterministically, but we still want to give the model some information about how to think about these things. Once you have done all of that, right, you could then have the agent deployed to your favorite place. We recommend using Agent Runtime. You could also use Cloud Run, GKE. But when you're thinking about building agents in 2026, it's not about just, okay, what model I choose and what agent framework I use. It's more about how do I give the agent the right tools, the right skills, and the right like the place to run so that it can scale to the place you need to scale to, as well as it has the right tools to be able to do the task at hand. And again, this is going to continue to evolve. We're going to learn more, and we're going to have more things. Like ADK just released this 2.0 release. It has a nice new, like a graph-based feature now. So we'll be able to build much bigger and better agents in 2026 and onward. Demo we build out for next is going to be a good reference point for all of you to start building agents in 2026. We have the Codelab that you can go follow this agent as well as other agents. We also have the code for the simulation application that we can go clone and try it out yourself, as well as try out ADK and Gemini together, build your agents in 2026.